Erosion and deposition of soils. It isn't pretty, but we need to talk about it. The first thing I need to say is that it's important for all of us to understand that soils are far more important to humanity than most people think about. Um, Without soils, there isn't agriculture. Without agriculture, there isn't people. We need this, and it is a non renewable resource, meaning that we can't get more of it. The world has a certain amount of it. Yes, it does new soil does form over time, but not in a time span that humans can wait for. So if we lose it, we can't get it back within our lifetime. So for that reason, we consider it non-renewable. And if you're going to be an informed voter and an informed member of society, you really should have an awareness of the importance that soils play and how important it is for us as a society to protect them. Now, erosion is really the main thing we're worried about here. So erosion is basically just the removal of soil material from a given area. I say soil, but it could be any surface material. And generally speaking, erosion is caused by the movement of either wind or water that takes components of soil from one place and carries it away. Now, because heavier particles are harder to move, what we find, and lighter particles therefore easier to move, what we find is that the lighter components of soils, that'd be silts and clay minerals, they are easier to move away. And so we find is that when erosion takes place, what it tends to leave behind, you can even see it here, it tends to leave the gravel and the sand behind and take away the silt and the clay. Well, the importance of silt and clay is they're very important for soil retention properties, water retention properties of soils. And so when you take those components away, the silt and the clay, you end up with soil that is less able to retain water and support plant growth. Now, how can we prevent soil erosion from happening? Well, first of all, we need to understand that the best way to keep soil where it is with plant roots. Plant roots hold soil in place. So anything we do that takes plants away and exposes bare soil is going to result in erosion. And so what we find is that bare soil, like plowed fields that don't have anything on them, they're at risk. So when rain falls on them, you can see it carrying the clay minerals away here. That's why we've got that brown color here. We can see it blowing the clay and the silt into the air, making a dust storm. So basically, exposed land without plants growing on it, is at risk of erosion. Now, the steeper the land is, the more at risk it is for water erosion, which is one of the more pronounced and effective means of removing soil. Now, this isn't agricultural per se, but forestry practices. A common forestry practice is called clear cutting, where you simply take all the trees off the land. And we'll talk about this later in the year. Well, when you do that, now I have very little in the way of plant material here. So what we find then is clear cutting definitely tends to lead to increased erosion. And the material on the hillsides, mostly the silts and the clay minerals, will end up swept away and end up in the streams down below. Now here's a soil erosion map of the world, and you see it's color coded from low, which is in light green, to moderate, high, and very high. And you can see there's definitely reasons for concern. There's places where farming has caused a lot of erosion. A lot of Europe has had problems with it because they've been doing it a long time. Here in Asia, unfortunately, Korea. So basically, soil erosion is a serious problem. It's one that can be mitigated. It has been traditionally. People, for the longest time, engaged in agricultural practices that did not lead to erosion. And we'll study this again later in the year. But for right now, we just want, as long as we're talking about soils, we should talk about what puts soils at risk. Now, what happens after it gets eroded? Well, keep in mind that it is the heavier particle is, the harder it is to keep it in suspension. So suspension means bouncing along in the air, carried by the air, carried by the water. So what we find then is the larger particles tend to erode less, and the smaller particles tend to get carried further. So what happens is, as it gets carried along, eventually you get to a point where the water velocity slows down. Maybe it enters a lake or the ocean or a flat stretch of land. But the bottom line is, whenever the speed of the water goes down, what happens is the larger particles fall out first. So like the gravel then the sand, then the silt, then the clay. So we call this deposition. So we have erosion followed by deposition. And deposition tends to be, whereas erosion required fast moving wind and water, slow moving wind and water tends to then deposit that material which it eroded, and it tends to sort it out by particle size because when you reach a certain minimum velocity, a certain component will fall out. So what we find then is deposition has a tendency to sort out the sand from the silt from the clay. And here's a graphic trying to show that same thing. I think my face is in the way of the clay, but you get the idea that as you reduce the velocity of the river from its source up in the mountains, where you can actually move boulders, to the river mouth, where the only thing that's going to stay in suspension is the clay. Now, here's I mean, it's a little bit blurry, but I think it gets the point across. So we see here is a river meeting the ocean. And when that happens, what we find is that sand tends to get deposited on the shoreline because sand is a little bit large. Of the three primary particles of soil, sand is the largest. Well, sand is the first to fall out. So waves come in, they stir up the sand, but then as soon as the wave stops moving, the sand just falls back down. So sand doesn't stay suspended very well, not in an ocean environment. So it tends to be only found on the shore. The silt tends to fall out of the water just beyond where the waves break. So if you were to swim out past where waves break and you go down the bottom, you'll find it's not really sand anymore. It's more silt down there because that's where it's going to settle out. And then the clay material can get carried quite far away. And that clay will go out to sea quite a ways and then settle out because any motion in the water at all will keep that clay in suspension. But again, all of it got eroded, but then it got deposited. Deposition happened according to its particle size. Now, erosion is a natural phenomenon too, and even without human interaction, it does occur. So let's just look at what it means in terms of soil formation on hillsides. So remember the more energy water or wind, in this case we'll look at water, has, the bigger particles it can move. So what happens is if we have a steep hill, what we find is that on the steeper parts, when rain happens, especially when it happens quickly, the rain moves pretty quick. So it can do a lot of eroding here. So as a result, the soils are thinner, and a lot of the clay particles and silt particles get stripped away. So we end up with is soils that are not very rich in nutrients or water retaining particles. As you get towards the bottom of the hillside, the slope becomes more gentle. The rain isn't moving as fast. Now, some of the material up here will get deposited here, but most of it will just keep on moving until it gets to the flatland. So what we find is the flatland tends to have really good soils that were transported, eroded, and then transported away from the upper slopes. So we find typically is the best agricultural soil is found at the bottom of slopes, and on the hillsides themselves, we have poor quality soils. So what kind of agricultural practices can we engage in that will reduce the likelihood of erosion? And again, like I said, we have a whole section of this course that talks about this. But for right now, let's just talk about it. For one thing is, don't leave the soil bare. If you leave the soil bare, it's at risk of being eroded. So engage in practices that leave, so you might till the soil, but you want to leave some of last year's material there so its roots are still there. So don't take it all up, leave some of it behind. Build terraces. So, if you've been to like Vietnam or Bali, China, I mean, I love this, but they have it in Korea too. There's places where you have terraced hillsides. So the idea is the water can't flow down the hill because you built a series of stairs. So there's really no slope except in that one little drop off between one terrace and the next. And this tends to definitely reduce the rate of soil erosion. So there's places where they've been doing this for thousands of years and the soil is still great. Another thing you can do is what's called contour tilling. So typically farmers just want to go straight. It's easier to drive your tractor that way. It's more time efficient, more fuel efficient, more money efficient, but it's not very good for the soil. So what they find is if you plant your fields by following the curvature of the land, by basically always driving perpendicular to right here, if I was to let water down the hillside, it wants to go this way, till perpendicular to that reduces water erosion. Another one is to prevent wind erosion is to leave trees fairly, don't have these wide open patches of land. Have some trees that form these windbreaks so you don't get high velocity winds that can carry away the silt and the clay particles. Another thing that's a problem for soils, that this doesn't have to do with erosion necessarily, is compaction. So a lot of heavy farm equipment has a tendency to compact soil. So you should know that if I take soil that is uncompacted, it has a lot of porosity. There's a lot of pore space here. And when I have a lot of pore space, I often have good permeability, which allows water to drain. So this uncompacted soil has porosity, which can hold water, and permeability, which allows it to drain, not become waterlogged. When I compact the soil, what happens is there's less pore space, so it can retain less water, and what water it gets doesn't tend to drain very well. So compacting of soil is an issue that uh, bad farming practices can do this pretty much irrevocable harm to the soil. And here's a soil compaction map of the world. And you can see, where's all the red? Well, this is basically where people do a lot of agriculture. So where people have a lot of farm equipment, lo and behold, they've done a lot of compaction of the soil. And again, that has a pretty negative influence on the ability of that soil to support agricultural purposes. So that's it. Not too hard. Anyway, that's it.